N factor, this is also called valence factor. N factor is also called valence factor, right? Valence factor, and it is just a number. N factor is just a number. N factor is just a number. It is valence, also called valence factor. It is just a number, right? So for acids, N factor is number of replaceable H plus ions. For acids, N factor is number of replaceable H plus ions, right? H plus ions. For bases, N factor is number of replaceable OH minus ions, right? For bases, N factor is number of replaceable OH minus ions. Next, for salts, the N factor is, right, total number of positive charge on cation, total number of positive charge or cation, or else we can also say total number of negative charge on ion. In a reactions, right? In a redox reactions, we are also going to calculate the N factor for oxidizing and reducing agents, right? So in a redox reaction, we are also going to calculate N factor for oxidizing and reducing agents, right? So the N factor for oxidizing and reducing agents is, right, so number of electrons, number of change in oxidation number per entity, right, per entity of a molecule. I repeat, valence N factor is also called valence factor. It is just a number. For acids, N factor is number of replaceable H plus ions. For bases, number of OH minus ions. For salts, total number of positive charge present on cation, or total number of negative charge present on anion. And for redox reaction, N factor we can calculate for, in a redox reaction, N factor we can calculate for oxidizing and reducing agents, right? So for oxidizing and reducing agents, the N factor is change in the oxidation number per entity in a molecule. We are going to calculate the N factor for ions, acids, bases and salts as well, right? If you calculate the N factor for ions, the charge on the ion is its N factor. Na plus ion, the charge on the sodium is 1, so its N factor is 1, right? The sodium and N factor is 1. If you take the magnesium, the charge upon the magnesium ion is 2, the charge upon the magnesium ion is 2, so its N factor is 2. The charge on the Ag plus silver ion, the charge on the Ag plus is 1, so Ag plus ion N factor is 1. Al plus 3, the N factor is 3. Why it is 3? The charge on the aluminum plus ion, aluminum is plus 3, so its N factor is 3. So Cl minus ion, N factor is 1. The charge on the chloride ion is 1, so its N factor is 1. So for NH plus 4 ion, the N factor is 1. The charge on the molecule NH4 plus is 1, so its N factor is 1. SO4 2 minus, the charge on the sulfate ion is 2 minus 2, so its N factor is 2. And one more thing important, while writing the N factor, don't mention the charges, whether it is cation or anion. So N factor is just valence number, it doesn't have charges. So for ions, the charge on the ion is its N factor. While coming to the acids release H plus ions. In reactions, acids release H plus ions. So the N factor for an acid is how many H plus ions it is going to be released. That is the N factor for the acid. So acid N factor is the number of H plus ions released by acid is called its N factor. If HCl, it releases 1 H plus ion, so its N factor is 1. Okay, its N factor is 1. H2SO4, observe carefully. If you see the structure, so how to write the structures I will explain later. If you see the structure, there are two OH groups. If you see the H2SO4 structure, there are two OH groups. In some of the reactions, only one H plus will be released, right? So between the two OH groups, in some of the reactions, only one H plus group will be released. If it releases only one H plus group, its N factor is 1, right? If it releases two H plus groups, its N factor is 2, right? N factor is how many H plus ions it is going to be released. If H2SO4 in reaction if it releases only one H plus ion, so its N factor is 1. In reactions H2SO4, if it releases 2 H plus completely, then its N factor is 2. Right? While coming to the H3PO2, if you observe the structure, and one thing you make sure here, so the H plus ion will be released from OH group only. The H plus ion will be released from this OH group only, from pH. Here also we have P bond H. This, the hydrogen ions which are attaching to the phosphorus, that are not going to be released, right? That are not going to be released. So since it has only one OH group, the N factor for H3PO2 is 1. Okay. Coming to the H3PO3, if you see, there are two OH groups. In H3PO3, if you see, observe the structure, there are two OH groups. In some reactions, it is going to be released 1 H plus. At the time, its N factor is 1. If it releases 2 H plus groups, so if N factor is 2. So H3PO3, based on the involvement in the reaction, based on the releasing the number of H plus ions, its N factor is 1 or 2. Right? H3PO4, it has 3 OH groups. In some reactions, it releases only 1 H plus. In some reactions, it releases 2 H plus groups. In some reactions, it releases 3 H plus groups. So its N factor also 1, 2, 3. Maybe 1 or 2 or 3. So if you observe carefully, right, you can understand this. H3PO4, this molecule, H3PO4, when reacts with 1 mole of NaOH, so only 1 H plus is getting replaced. See, H3PO4, only 1 H is getting replaced with sodium, and right, that's why its N factor is 1. In the second case, H3PO3, Na2, two hydrogens are getting replaced with sodium cations. In the second case, in H3PO4, 2 hydrogens are getting replaced with sodium cations. So in this case, N factor is 2. If you come to here, H3PO4, it is completely converting to the Na3PO4. That means 3 hydrogens are completely getting replaced by sodium cations. So its N factor is 3. So for acids, based on how much H plus ions it is releasing, right? So based on that, we can calculate the N factor for acids. So one more exception I want to explain here, right? If you take boric acid, what we think, if you, by measuring the name itself, what we think, boric acid means, so it is acid, it releases H plus ions, that we think. But boric acid is an exception. Boric acid is a Lewis acid. When it undergoes hydrolysis or when it reacts with water, it takes OH minus. It doesn't release H plus ion. Even though it is boric acid, it doesn't release H plus ion. It takes OH minus ion from water and it forms a complex BOH4 minus. Observe here, water has H plus and OH minus ions. This BOH3, when react with water, right, it forms BOH4 minus plus H plus. It forms like this. Okay. So this boric acid we can also write as H3BO3. So this is an exception. Boric acid doesn't release H plus. Even we are calling it an boric acid, right? It accepts OH minus, right? And it forms complex BOH4 minus. The acid which doesn't release H plus ion is boric acid. This is an exceptional case. Remember this. Okay. Now coming to the bases, as is what we said, the number of H plus ions released is its N factor. For bases also the same case. For bases, the number of OH minus ions released. Bases, the number of OH minus ions released is its N factor. So NaOH, it can release only one OH minus ion, right? So its N factor is 1. MgOH twice always releases 2 OH minus. 2 OH minus it releases. It's not the case like it releases only 1 OH minus ion, 2 OH minus ion, 2, not like that. Magnesium hydroxide means always it releases 2 OH minus ions. So N factor for magnesium hydroxide is 2. Okay. So aluminum hydroxide, the N factor is 3. So this FeOH thrice and SnOH4 involved in oxidation and reduction reactions, right? Involved in oxidation and reduction reactions that I explained you. Now you remember FeOH thrice, the N factor is 3, SnOH4, the N factor is 4. Coming to the salts, what is the salt N factor? The total charge present on cation or VAR, not ARE, right? The total charge present on the cation or the total charge present on the anion. If you take Na plus Cl, it has Na plus and Cl minus ions. Na plus and Cl minus ions. So what is the total charge present on the cation? 1. So its N factor is 1. No sir, I will take anion. Take Take whether cation you can take or anion you can take. If you take anion, take only Cl minus. So what is the charge present on the anion? 1. So its N factor is 1, right? So NaCl N factor is 1. MgCl2, how it will be? Mg plus 2 and 2Cl minus. MgCl2 is Mg plus 2 and 2Cl minus. So the charge present on the cation is 2, N factor is 2. Or if you want to take anion, Cl minus. Each Cl is 1, 2 Cl are there, 2 Cls are there, 2 Cl minus are there. So it has total charge is 2 minus 2. So the N factor is 2. MgCl2, the N factor is 2. Okay. MgCl2, the N factor is 2. AlCl3, Al3 plus and 3Cl minus. So what is the charge? Al3 plus. 3 plus is there, so N factor is 3. If you take 3Cl minus, each Cl is minus, 3Cl minus means minus 3. So N factor for AlCl3 is equal to 3. N factor for AlCl3 is also 3. So K2SO4, Al2SO4 thrice 24H2. This is an alum. We are going to calculate the N factor for this. This is potash alum. We are going to calculate N factor for this. So 24H2O, no need to calculate. 24H2O is a covalent compound, not a salt. So that we are not going to take an H2SO4 into account here, right? These K2SO4 and Al2SO4 thrice both are salts. We need to take either total charge on the cation or total charge on the anion. First we will take total charge on the cation, right? So each potassium is plus. There are 2 potassium ions, so plus 2 will come. Each potassium is plus 1, K plus, right? So there are 2 potassium ions, plus 2 will come. If you take aluminum, each aluminum is plus 3. There are 2 aluminiums, so plus 6, right? Al2SO4 thrice is there, right? Each aluminum is plus 3. There are 2 aluminiums, so plus 6. So the total charge on the cation is plus 8. So N factor is 8. So N factor is 8. No sir, I will take anion. Take anion also. You will calculate now. If you take anion, each SO4 is minus 2. Here SO4 thrice means each SO4 is minus 2. SO4 thrice means 3 into minus 2. Each SO4 is minus 2. SO4 thrice means 3 into minus 2. So it is minus 6. So minus 2 minus 6, what will come? Minus 8 will come. So minus 8 means N factor is 8. N factor is 8. You can take cation or anion. If you take both, same value is coming. One thing you remember, when writing the N factor, don't mention the charges. Don't say plus 8 or minus 8 plus 1 or minus 1. It is just a valency number. You always just mention without avoid charges while mentioning the N factor. Okay. We are going to calculating the N factor for oxidizing and reducing agent. For the first compound, right? First we need to calculate the oxidation state. First we need to calculate the oxidation states for each compound or each ion. And then we need to find the change in the oxidation state. First calculate the oxidation state and calculate the change in the oxidation state per entity that I will explain you, right? If you calculate, so I will take the sulfur iodine over here, sulfur iodine, right? If you take the sulfur, if you calculate the oxidation state for this sulfur, it will come, this is my oxygen is minus 6, okay, minus 6, this is a plus 4. So this sulfur is plus 2 will come. Okay. So this sulfur oxidation state is plus 2. If you calculate for this sulfur, this is 2.5 will come. Plus 2.5 will come. This sulfur oxidation state is plus 2. This sulfur oxidation state is plus 2.5. Here iodine oxidation state is 0. Ion oxidation state is minus 1. First we have calculated the oxidation states. Then we need to calculate the change in the oxidation state. Here the change in the oxidation state is 0.5. Here the change in the oxidation state is 0.5 and there is increase in oxidation number so it is oxidation reaction. Now coming to the iodine, right? The change is 1. 0 to minus 1 means 1, right? So there is 0 to minus 1 means decreasing, so it is reduction reaction, right? It is reduction reaction. To calculate the N factor for the reactions, first calculate the individual oxidation states and then find the change, then calculate the change. Here you observe carefully, per entity we are asking for 2 sulfur atoms, right? For each sulfur there is change is 0.5. Each sulfur change is 0.5. For 2 sulfurs the change is 2 sulfurs, 2 into 0.5, 1. So the N factor for S2O32 minus is 1. So the N factor for S2O32 minus is 1. Okay, I repeat. First calculate the individual oxidation states. Sulfur it is 2. It is 2.5, right? The change is 0.5. For 1 sulfur it is 0.5. 2 sulfurs it is 1. So the N factor for S2O32 minus N factor is 1. Okay. Iodine it is 0. Iodine is 0, right? The change is 1. The change is 1. For each iodine it is 1. For 2 iodines it is 2, right? So the N factor for iodine is 2. Okay, the N factor for iodine is 2. While coming to here, right? So for each sulfur the change is 0.5. For S4O6 2 minus, each sulfur the change is 0.5. Since there are 4 sulfurs, so 4 into 0.5, so the N factor for S4O6 2 minus is 2. Okay, so coming to the I minus, right? The change is 1. There are single iodine only, so the N factor for I minus is 1. Okay, so we need to calculate in such a way. Okay, such a way we need to calculate. First calculate the individual oxidation states, then find the change, right? So for finally per entity, so this S2 is an entity. This S2 is an entity. Here this I2 is an entity. Here the S4 is an entity. So total change in oxidation state per entity is its oxidation number. Now we will do for this, then you will get very clear idea. If you take here the chromium oxidation state is plus 6. Okay, the chromium oxidation state is plus 6. Here it is plus 3. So what is the change? The change is plus 6 plus 3 means the change is plus 3. For each chlorine it is plus 3. For each chromium it is plus 3. Since there are 2 chromiums, so N factor equal to 2 into 3, that is equal to 6. How to calculate oxidation state? I have shown you already. How to calculate oxidation states? I have shown you already. So here I am not explaining, right? If I explain also you feel bored, that's why I am directly writing here. So here in Cr2O2 minus, each chlorine oxidation state is plus 6. The change is plus 3. So per entity means 2 chromium atoms. Per entity means 2 chromium atoms. So 2 into 3 6. So the N factor for this reaction is 6. And coming to here, right? This MnO4 minus, here the oxidation state is plus 7. MnO4 2 minus, the oxidation state is plus 6. The oxidation state is plus 6. So what is the change? 1. Plus 7 plus 6. What is the change? Only 1. So the N factor is 1. The N factor is 1. Here coming to here, it is plus 7, it is plus 4. What is the, it is plus 4 in neutral medium. So in different medium, it formed different ions. KMnO4 in different medium, it formed different ions. In neutral medium, it forms Mn4 plus ion. So here it is plus 7, it is plus 4. What is the N factor? N factor is 3. For Mn4 minus ion, the N factor is 3. So here, in acidic medium, it forms Mn2 plus. In acidic medium, it forms Mn2 plus. What is the change? Plus 7 and plus 2, 5. So the N factor in acidic medium is 5. Okay. So MnO4 minus in basic medium, N factor is 1. In neutral medium, N factor is 3. In acidic medium, N factor is 5. So we can give the conclusion. So here MnO4 is getting reduced. Mn4 decrease in oxidation number is reduction. So here MnO4 minus undergoing reduction, that means it acts as oxidizing agent. So it is undergoing reduction, that means it acts as oxidizing agent. So in acidic medium, it is stronger oxidizing agent than neutral medium, right? So in neutral medium, it is stronger oxidizing agent than basic medium. So the oxidizing order is acidic medium greater than neutral medium greater than basic medium, right? So this is the oxidizing nature order of the MnO4 minus, right? Next coming to here, I need to calculate the N factor, right? So NO3 minus, based on the different reactions, it is giving different compounds. NO3 minus in different reactions, it is giving different compounds. I need to calculate the N factor for this, right? NO3 minus, the nitrogen oxidation state is plus 5. In NH4, this oxidation state is minus 3. Okay, minus 3. So what is the N factor here? Plus 5 to minus 3 means 8. Okay, the n factor is 8. Plus 5 to minus 3 means plus 4, plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. So n factor is 8 over here. So coming here, NO2 means plus 4. In NO2, nitrogen oxidation state is plus 4. So the difference is 1. So the n factor is 1. Okay. Here NO, nitrogen oxidation state is plus 2. In NO, nitrogen oxidation state is plus 2. Plus 5 and plus 3. The difference is 3. So the n factor is 3. So while coming to here, right? So here nitrogen oxidation state is plus 1, right? The nitrogen oxidation state is plus 1, plus 5 plus 1. What is the difference? 4. So here nitrogen n factor is, so here in this reaction, while converting NO3 minus to N2O, right? So the n factor is 4. Next coming to here, if you observe this reaction, single compound is giving two products. Here there are two reactants are there, two products are there. Here two reactants are there, two products are there. Here one reactant, one product we have taken. One reactant, one product. Here two reactants and two products. Here one reactant and two products. So how to calculate the n factor for this? One reactant and it is given the two products. How to calculate the n factor for this? So for this you can calculate the n factor, right? N factor equal to here n1 plus n2. N factor equal to n1 plus n2. We can calculate in such a way, right? So in Cu2S, copper oxidation state is plus 1, sulfur oxidation state is minus 2. In SO2, sulfur oxidation state is plus 4, right? Copper oxidation state is plus 2. First check for the copper, right? There is increase in oxidation state plus 1, right? There is increase in oxidation state plus 1. Since there are so two coppers, so the n factor for copper is 2. Okay, so here the copper, I repeat, in copper oxidation state increase in plus 1. Since there are two coppers per entity we need to calculate, so n factor for copper equal to 2. If you calculate for sulfur, right here it is minus 2 to plus 4. Minus 2 to plus 4 means the difference is 6. So here n factor for sulfur equal to 6. N factor for sulfur equal to 6. So n factor total we need to calculate. So n factor equal to n1 plus n2. So here you can calculate 6 plus 2, that is 8. If you calculate n1 equal to 2, n2 equal to 6, so 8 will come. So the n factor for Cu2S reaction is 8. This reaction is same as above. So what will come here? So n1 plus n2 will come here. If you check the oxidation state, iron is plus 4, sulfur is minus 4. Okay. So here Fe is decreasing 1, iron oxidation number is decreasing 1, so its n factor is 1. Sulfur, if we take for entity minus 4 to, per entity we need to take, so minus 4 to plus 6. Minus 4 to plus 6 means, there is change is 10, right? There is change is 10. So n factor for this, for sulfur over here is 10. So the total n factor equal to n1 plus n2. So for FeS2 molecule, the n factor is 11. For FeS2 molecule, the n factor is 11. How the questions will come based on the n factor? How the questions will come based on the n factor? So based on this n factor, the examiner can ask you three kind of questions. The first one is equivalent weight calculations. The second one is normality calculations and the redox titration calculations. These three kind of questions examiner will ask you based upon the n factor. Now I am going to show you how to do the calculations. Equivalent weight is a unitless quantity, right? Remember two things. Equivalent weight is a unitless quantity. If you calculate equivalent weight in grams, it is called gram equivalent weight. Equivalent weight is generally a unitless quantity. If you calculate it in grams, it is called gram equivalent weight. Equivalent weight equal to molar mass by n factor. If you know the molar mass of any compound, you can calculate the equivalent weight. So equivalent weight equal to molar mass by n factor, right? So I am going to solve these three questions for you and you will get clear idea. First, generally remember, equivalent weight of hydrogen is 1, oxygen is 8, equivalent weight of fluorine is 35.5. So these will helpful in solving the problems, right? First, in this question, in the reaction, N2 is getting converted to NH3. So what is the equivalent weight of nitrogen? Question is this, in a question, nitrogen is getting converted to NH3. What is the equivalent weight of nitrogen? So how to solve this? First write the formula for equivalent weight. What is the formula for equivalent weight? Equivalent weight equal to molar mass by n factor. What is the formula? Equivalent weight equal to molar mass by n factor. So here nitrogen molar mass is 28. So nitrogen molar mass is 28. So n factor we need to calculate. So what I told you, first write the oxidation states. Nitrogen oxidation state is 0. In NH3, N oxidation state is -3. So what is the change? 0 to -3. So 0 to -3, the change is 3. The change is 3. So for one nitrogen it is 3. N factor is always the number of electron changed per entity. Here the entity is N2. In entity there are 2 nitrogens are there. So 2 into 3, 6. So the N factor is 6. Students often do mistakes here. They will just put 28 by 3, not 3. So for single electron, for single nitrogen the change is 3. For 2 nitrogens the change is 6. So here 28 by 6. If you calculate this, 14 by 3 will come. So this is the equivalent weight of nitrogen. Equivalent weight of nitrogen. If you calculate the equivalent weight of NaCl, so just write the formula. Equivalent weight equal to molar mass by N factor. Molar mass by N factor. What is the NaCl molar mass? 23 plus 30. Sodium mass is 23. Chlorine mass is 35.5. So N factor for NaCl equal to 1. So 58.5 by 1, you will get 58.5. Right? So the equivalent weight of NaCl is 58.5. Right? So now we are going to calculate the equivalent weight for H2SO4. So the same formula you are going to apply. Equivalent weight equal to molar mass by N factor. So molar mass of H2SO4 is 98. Right? H2SO4 if nothing is given means its N factor is 2. If nothing is given means its N factor is 2. Why? It has 2 replaceable hydrogens. So its N factor is 2. So if we calculate, equivalent of H2SO4 is 49 will come. In such a way, we can calculate the equivalent weight, and they may ask the questions like this. Right? They will give the molar mass, or they will give the reaction, or they will give the molar mass, and they will ask you to calculate the equivalent weight. We will do 2 more questions on equivalent weight, then you will get very clear idea. Okay. Another question related to equivalent weight. So they have given the equivalent weight of metal oxide. They have given the equivalent weight of metal oxide, and they asked you to calculate the equivalent weight of metal, and equivalent weight of metal phosphate, and equivalent weight of metal sulfate. How to do this? I will explain you. So first, equivalent weight of metal oxide equal to equivalent weight of metal oxide equal to equivalent of weight of metal plus equivalent weight of oxygen. Okay. So equivalent weight of metal oxide equal to equivalent weight of metal plus equivalent weight of oxygen. Right? So now if you do this, equivalent of weight of metal oxide is given as 17. Equivalent weight of metal oxide is given as 17. So equivalent weight of metal we need to find. Equivalent weight of metal we need to find. Equivalent weight of oxygen is 8. I already told you equivalent weight of oxygen is 8. If you calculate the equivalent weight of metal, so 9 will come. Okay. So the equivalent weight of metal is 9. So equivalent weight of metal oxide equal to equivalent weight of metal plus equivalent weight of oxygen. So now we know the equivalent weight of metal is 9. So if we find equivalent weight of metal is 9. Now we are going to calculate the equivalent weight for metal sulfate. So what is the equivalent weight for metal phosphate? What is the equivalent weight for metal phosphate? Right? So equivalent weight of metal, right? Equivalent weight of metal plus equivalent weight of phosphate. Equivalent weight of metal plus equivalent weight of phosphate. Isn't it? Equivalent weight of metal phosphate equal to equivalent of weight of metal plus equivalent weight of phosphate. Right? Equivalent of weight of metal. So if you take 9 will come. 9. Equivalent weight of metal is 9. So 9 plus phosphate is PO4 3 minus. Phosphate is PO4 3 minus. So 9 plus, so equivalent weight of phosphate is equal to molar mass by N factor. Equivalent weight of phosphate equal to phosphate molar mass by N factor. What is the phosphate molar mass? We calculate 31 plus, right? 31 plus 64 by 3. Isn't it? Phosphorus is 31, oxygen O4 is 64 by 3. If you calculate this, 9 plus 90, 9 plus 95 by 3 will come. Right? We can do the remaining calculation. So in such a way we can calculate the equivalent weight of metal phosphate. Metal plus equivalent weight of phosphate. Metal we know, right? The phosphate molar mass is this 31 plus 64, oxygen 64. Why we are putting is 3? Its N factor is 3. For a ion, for a compound ion, the charge upon it is N factor. So we are putting N factor 3 over here. 9 plus 95 3. If you do the calculation, so equivalent weight of metal phosphate will come. For equivalent weight of metal sulfate, same. Equivalent weight of metal sulfate equal to equivalent weight of metal plus equivalent weight of sulfate. Equivalent of metal plus equivalent weight of sulfate. Equivalent weight of metal is 9. equivalent weight of sulfate is, so SO4 2 minus, right? Here 9 plus SO4 2 minus means 32 plus, right, 64 by 2. 32 plus 64 by 2. Okay. So what it will come? 9 plus 96 by 2 come. 9 plus 48, right? Around 57. It is coming around 57. In such a way, we need to do the calculations when the examiner give the questions in NEET or JEE. Okay. Discussed how n factor is useful to calculate the equivalent weight. Now we do n factor. We involve n factor in doing normality calculations. Now we involve n factor in doing normality calculations, right? So in normality calculations, n factor, there are so many formulas that in detail I will discuss in solutions chapter. For this chapter, just remember the relation between the normality, molarity and n factor. Normality, molarity and n factor, right? There are so many formulas. For this redox reactions, just remember one formula. The remaining formulas I promise you I will detailedly explain in solutions, right? Now remember this formula and calculate the redox reactions, right? So in this question, they asked us to calculate the normality. They asked us to calculate the normality, right? So to calculate the normality, just use the formula normality equal to molarity into n factor, right? If you use this formula, your calculation will be simple and you won't do mistakes, right? So first calculate the molarity, right? What is the molarity formula? Moles by molar mass, right? Into 1 by V into n factor. Okay. 1000 by VML into n factor. So first write the normality formula. What is the normality formula? Molarity into n factor. Normality equal to molarity into n factor. So n equal to molarity equal to moles by molar mass into 1000 by V in ml into n factor. Right. Now I am going to substitute these values. Right. So if I substitute this, so moles. So right here moles equal to weight by molar mass. Moles equal to weight by molar mass. So what is the moles weight here? Weight of the oxalic acid is 18.9. Weight of the oxalic acid is 18.9. And molar mass of the oxalic acid is, if you calculate, each carbon is 12, 2 carbons it is 24, right? 4 oxygens it is 64, 4 oxygens it is 64, 2 hydrogens 2, 10, 90, right? 90 is coming. The molar mass of oxalic acid is 90. Can we repeat? Each carbon is 12, 2 carbons 24. Each carbon is 6, each oxygen is 16, 4 oxygen 64. Okay. Each hydrogen is 1, 2 hydrogens 2. So 90 is the molar mass for oxalic acid. So 90 put over here into 1000 by, right? Volume they have given 300 ml into n factor for oxalic acid is 2. N factor for why it is 2? See, there are 2 OH, right? So if we didn't mention anything, means we need to assume that 2 hydrogens are released by oxalic acid. If he mentions only 1 H plus is released, then we need to take the n factor as 1. If he didn't mention, we need to assume that both hydrogens are going to be released. That's why you have taken n factor as 2, right? If you do the calculation, so the normality of the solution will come, right? So to remember this formula, while n factor is involving and they asked you to calculate the normality, remember this formula, right? And substitute these moles equal to weight by molar mass, right, into 1000 by volume they will give, and n factor. If you do the calculation, so right, you will get the normality for the given question, right? So now we will do for this, right? So calculate the 14.8 grams of CaOH twice in 200 ml solution, right? First use the formula normality equal to molarity into n factor. Normality equal to molarity into n factor. So here molarity equal to weight by molar mass into 1000 by V in ml into, right? Yeah, so n factor. Okay. So what is the mass they have given? 14.8. So what is the molar mass of CaOH twice? Calcium is 40, right? Oxygen is 32, hydrogen is 2, right? 74. Okay. 74 is the molar mass for calcium hydroxide. Okay. Next into 1000 by how much they have given volume? 200, right? N factor is 2. N factor is 2. Why? There are 2 replaceable OH2 minus ions. So N factor is 2. So now we can calculate the normality of the given question. Right? I request you students calculate and give the answers in the comment section. I request all of you students calculate these two questions and give the answers in the comment section. Okay, now we will do the redox reaction calculations. After completing equivalent weight is completed, normality calculations are completed. Now we will do the redox reaction titration calculations. Okay, doing the normality calculations, right? You know the molarity formula. Molarity equal to moles by volume. Molarity equal to moles by volume. So in the place of moles for normality, gram equivalents will come. Right? Molarity equal to moles by volume, that you know. In place of moles for normality, gram equivalents will come. Normality equal to gram equivalents by volume. And there you have a relation between the gram equivalents and moles. If you know the moles, we can convert them into gram equivalents. If you know the gram equivalents, we can convert them into moles by using the formula gram equivalents equal to moles into n factor. Gram equivalents equal to moles into n factor. Just remember one thing, molarity equal to moles by volume, normality equal to gram equivalents by volume. We can convert the moles into gram equivalents or gram equivalents into moles, right? So gram equivalents equal to moles into n factor, right? There is a relation between. So by using the n factor, we can convert them, and also there is a equivalent weight and molecular weight, right? Equivalent weight equal to molecular weight by n factor. Molecular weight by n factor. In previous video, I explained you, right? In previous video, I have explained you E of H, E of oxygen, and E of chlorine, right? E of H, E of oxygen, and E of chlorine, right? So equivalent weight equal to molecular weight by n factor. So E of hydrogen is molecular weight is 1, n factor is 1, so equivalent weight of hydrogen is 1. Equivalent weight of hydrogen is 1. If you take oxygen, its molecular weight is 32, its molecular weight is 16, its molecular weight is 16, right? So oxygen n factor is 2. Generally oxygen n factor is 2. If you calculate the equivalent weight of oxygen is 8. If chlorine is generally n factor is 1. Generally it forms Cl minus ion. Chlorine generally it forms Cl minus chloride ion. Its n factor is 1. If you calculate equivalent weight, molecular weight by n factor, molecular weight of chlorine is 35.5. Its n factor is 1. So equivalent weight is 35.5. Right? So there is a relation between equivalent weight and molecular weight also. Equivalent weight equal to molecular weight by n factor. So by using the n factor, we convert the gram equivalents into moles, or equivalent weight into molecular weight, or molarity into normality. You can do three things by using the n factor. We can convert the gram equivalents into moles, or we convert the normality into molarity. We can convert the equivalent weight into molecular weight if you know the n factor, or by using the n factor. Okay. While calculating the titrations also, n factor involves. While calculating the acid-base titrations or redox titrations, we are going to use n factor for calculation purposes. The question also will come based on n factor for these purposes, right? So first to understand redox titration. So if in this reaction, how can we decode this? 1 mole of A reacts with 1 mole of B, right, and form 1 mole of C and 1 mole of D. How can we decode this? 1 mole of A reacts with 1 mole of B and forms 1 mole of C and 1 mole of D. If you say in terms of gram equivalents, right, we can also say this in terms of gram equivalents. Gram equivalents, how we are going to say that is 1 gram equivalent of, right, 1 gram equivalent of A reacts with 1 gram equivalent of B. 1 gram equivalent of A reacts with 1 gram equivalent of B and forms 1 gram equivalent of C and 1 gram equivalent of D. Right? We can express the equation in terms of moles and gram equivalents also. If you express in terms of moles, 1 mole of A reacts with 1 mole of B and forms 1 mole of C and 1 mole of D. If you express this in terms of gram equivalents, 1 gram equivalent of A reacts with 1 gram equivalent of B and forms 1 gram equivalent of C and 1 gram equivalent of D. So coming to the second equation, how can we express this in terms of moles? 3 moles of A reacts with 4 moles of B. 3 moles of A reacts with 4 moles of B and form 5 moles of C and 4 moles of D. Observe carefully. 3 moles of A reacts with 4 moles of B and forms 5 moles of C and 4 moles of D. This reaction we have expressed in moles. Now the same reaction we are going to express in gram equivalents. Now the same reaction we are going to express in gram equivalents. Observe the magic over here. In gram equivalents, we always say again 1 gram equivalent of A reacts with 1 gram equivalent of B and forms 1 gram equivalent of C and 1 gram equivalent of D. Right? I request you students observe this carefully. When we express the equation, right, in gram equivalents, always it 1 will come. See, irrespective of the stoichiometric coefficient, when you express this reaction in gram equivalents, 1 mole will come. Right? I think now you understood the difference when we express the reaction in terms of moles, when we express the reaction in terms of gram equivalents. While doing the redox titrations or acid-base titrations, redox titration or acid-base titration, take the gram equivalents and solve the question. That will be easy for you. If you take gram equivalents, no need to write the equation, no need to balance the equation. You can take directly gram equivalents. I repeat, if you do the calculation in gram equivalents, no need to write the equation, no need to balance the equation also. Directly you can take gram equivalent of A equal to gram equivalent of B. Gram equivalent of acid equal to gram equivalent of base. Now you understood, I think. So that's why in redox titrations or acid-base titrations, we are going to use gram equivalent concept for to calculate the acid-base titration reactions. Now coming to the acid-base titrations, while doing the calculations, always take gram equivalent of acid equal to, right, gram equivalent of acid equal to gram equivalent of base. Right? In acid-base titrations, take gram equivalent of acid equal to gram equivalent of base. So we are going to solve these two questions. Before that, remember that moles equal to weight by molar mass. I am writing over here. Moles equal to weight by molecular weight. Moles equal to weight by molecular weight. Gram equivalents equal to weight by equivalent weight. Right? Gram equivalents equal to weight by equivalent weight. How equivalent weight will come? Equivalent weight equal to molecular weight by n factor. How equivalent weight will come? Equivalent weight equal to molecular weight by n factor. Now remember this equation. And one more important thing, right? Moles equal to, right? Gram equivalents equal to moles into n factor. Gram equals equal to moles into n factor. Remember that equation also. What is the relation between the moles and gram equivalents here? So gram equivalents equal to moles into n factor. And remember one more formula, right? Normality equal to molarity into n factor. While doing the gram equivalent calculation, you should have the idea of this. Moles equal to weight by molecular weight. Gram equivalents equal to weight by equivalent weight, right? So equivalent weight equal to molecular weight by n factor, and the relation between the moles and gram equivalents is gram equivalents equal to moles into n factor, and normality equal to molarity into n factor. Right? Now we are going to solve this question. So he asked us, right, 0.5 grams of acid was exactly neutralized by 20 ml of 0.5 NaOH, right? What is the basicity of the acid? He asked us to calculate the basicity of the acid. What I told you, first write gram equivalents of, do the calculation in terms of gram equivalents. Here, gram equivalent of acid equal to, right, gram equivalent of base. Gram equivalent of acid equal to gram equivalent of base. For acid, what he has given? He has given the mass and molecular weight. He has given the mass and the molecular weight. From mass and the molecular weight, moles will come. From mass and the molecular weight, I am writing here. He has given the mass and he also given the molecular weight. From mass and molecular weight, moles will come. But we need gram equivalents. So what is the formula we have? Gram equivalents equal to moles into n factor. That's why here I take the reaction into n factor. I will multiply with this with n factor. I repeat, he has given the grams and molecular weight. By the grams and molecular weight, moles will come. But I don't need moles here. I need gram equivalents over here. So to get the gram equivalents, so we have the relation moles into n factor. So this is the moles, this is the n factor. Now I am going to calculate the gram equivalent of base. We need to calculate gram equivalents of base over here, right? So normality is given, gram equivalents. What is the formula of normality? Right? Normality equal to gram equivalents, right? Normality equal to gram equivalents by volume. Okay. Normality equal to gram equivalents by volume. Molarity equal to moles by volume. Molarity equal to moles by volume. Normality equal to gram equivalents with volume. Since in the question he has given the normality and the volume. In the question he has given the normality and volume. So we need to calculate the gram equivalents. So we need to use this formula. So substitute over here, right? So then gram equivalents equal to normality, how much here? 0.5 into, so volume has given 20 ml, right? 20 by 1000. If you do, right? Now we can calculate the n factor. If you calculate, how much it will come, right? So here 0.5, if you calculate, 2 will come. So 2 will come. So the n factor of the given acid is 2. For acid, we used to call it as basicity. For acid, we used to call it basicity. For bases, we used to call it as acidity, right? So HCl, the basicity is 1. H2SO4, the basicity is 2. Acid, we used to say basicity. For bases, we used to say acidity. NaOH, the acidity is 1. For MgOH twice, the acidity is 2. In such a way, we need to calculate. So I repeat the question. So first acid base titration, understood? So you know gram equivalent of acid equal to gram equivalent of base. First write that one. So gram equivalent, for gram equivalents, you have 3 formulas. Based on the data given in the question, for gram equivalent you have these formulas. Based on the data given in the question, you need to apply the formula and you need to calculate. Here, gram equivalents of acid, he has given the moles, right? So he has given the moles. So we have the formula to convert the moles into gram equivalents equal to moles into n factor. That formula I have applied here and I substituted. Here we have, when normality is given, volume is given, we have the formula normality equal to gram equivalents into 1000 by V. I have applied this formula over here. Now if I calculate, the n factor is 2. Okay. Now I think going to the next question. If you observe the question, 2 grams of base. This is also acid base reaction. Equivalent weight is 40. Reacts with 3 grams of an acid. The equivalent weight of acid is. So here also first write gram equivalents of acid equal to gram equivalents of base. Right? So gram equivalent of acid equal to gram equivalent of weight. So here what is given? He has given the weight and equivalent weight. What is the formula we have? Gram equivalent equal to weight by equivalent weight. So based on the data given in the question, I am going to use this formula. So gram equivalent of weight by equivalent weight. For acid, weight is given as 2, right? So acid equivalent weight, for acid weight is given as 3. They asked us to calculate the equivalent weight of acid, right? For base, weight is given 2, equivalent weight is given as 40. I repeat, for acid, we are going to use this formula based on the data. Gram equivalents equal to weight by equivalent weight. For acid, they have given 3 grams and they asked us to calculate the equivalent weight of acid. For bases, they have given 2 grams and they have given the equivalent weight. If you calculate, right, 60 will come. So equivalent weight of acid equal to 60. In such a way, you need to do the calculations. First write all the formulas. Analyze the data and fix which formula is suitable for this question. First write all the formulas, analyze the question and fix which formula is applicable to this question, and based on that you solve and finally you can get the answer. Okay, understood?